Good morning, Tessa.
Good morning.
How are you?
Good.
That's good. Morning, Amron. Morning, Austin.
Morning. Good morning.
All right. Oops. Okay. So assignment's got to come in today, so we want to remember that, right?
Yep.
And yesterday we went through the start of absolute values. Did we go through? We went through that assignment this week already. All right, now we get some. I gave you the easy one yesterday. Got some work on 7.2. All right. So just quick refresh of yesterday. Yesterday we were talking about absolute value. So absolute value is taking a value such as -3 and saying what is the positive distance it is from 0. That's basically what we do. Or all you need to know is that if it's a negative inside the absolute value, it becomes a positive. That's essentially what happens. So an absolute value function is a function that involves the absolute value of a variable. This graph shows some of the functions and the related absolute values of functions. To graph an absolute value function, make a table of values and then graph the function. Use y equals f of x, y equals negative f of x to sketch the function. All right, so this is what we're going to do today is fairly significant in the fact that we need to use it in Precalculus 40S. So it's one of 5 graphs that we want to absolutely know in grade 12. They're starting the way they look to start with. Okay, so for example, there is the parabola. There's y equals x cubed. There is y equals the absolute value of x. Y equals the square root of x, and y equals the reciprocal. So those are 5 graphs that we want to know. So the first of them we've already done so much work on is the parabola. So the second is an absolute value graph. Okay, so rather than starting with what it looks like on the first page there, I'm going to do a little bit of, I'm going to show you how the very basic y equals absolute value x graph looks. So to start with, I'm going to graph the y equals x graph. Okay, so there's my y equals x graph. And so y equals x means whatever the x value is, the y is the same value as it. All right, so -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, so on. Okay, so that's simple enough. Now, what we want to be able to do is we want to be able to find out what y equals absolute value of x is. So what we learned yesterday is that if the absolute value of a negative number, if I take the absolute value of a negative number, it becomes a positive value. So when I look at these now, and I'm going to draw a second one here. So this will be my extra y. All right. So plug in -3 in for absolute value of x. So the absolute value of -3 is +3. Absolute value of -2 is +2. Absolute value of -1 is 1, 0, and then 1, 2, and 3. So what we notice is that all of the values that were negatives down here on my y equals x graph now have to become positives. So my new graph looks like this. That stayed the same. 1, 1, 2, 2, 3, 3, they all stayed the same. Those are those coordinates right here. 4, 4, and so on. What changes is this, in grade 12, we'll call it a reflection. Essentially what it is it flips up. So all of these negative values down here all become positive, and now I have the absolute value of x. So essentially what happens is I take this graph here, the original graph, which was my blue line, and anything that was negative now becomes positive in the y. All right, so it flips up and over. The easiest way to do it, if you're not 100% sure how this works, the easiest way to do it, I'm just going to try and square that a bit better. The easiest way to do it is write out your table of values, plug them in to your equation for x, and then flip them up. That's one way. To me, the easiest way is just to take whatever this is here and flip it up into the top. All right? Do a reflection over the x-axis. That's the x-axis right here. We flip it up and over. Okay? Now, they're going to talk about piecewise. I don't focus a lot on piecewise until grade 12. Absolute value of x right here. If I were to extend this line right here down into here, if I were to extend it in here, this is the graph of y equals negative x. All right? So what I have is this line right here is y equals x. I should have put that in blue. So I have y equals x is this line. And this line is y equals negative x. So the piecewise part of this. Now again, my focus isn't as much on this as it is in grade 12. Just a second, I'm running into a problem here. So what I need to do here is I'm going to explain to somebody how the absolute value of x graph looks based on these two graphs. I'm going to piece, they call it a piecewise. What that means is I take from one graph and a second graph, I take parts of them to create a new graph. Now again, this is not something that's 100% like super essential just yet. But here's how this looks. So I go f of x or y equals x, comma, negative x, comma. All right, I'm just going to make sure my notation's right. I think I've got one. Yeah. Okay. So what part of this graph right here, so this is my blue graph now, what part of it did I use to get the absolute value of x? I use this part right here. So I explain it from my domain, from my x values. Here's my part of the graph here. So what part of this graph did I use? I used where x was greater than or equal to 0. So to get my absolute value to 0. Okay? So that's down the line a little bit. What we're going to do right now is we are going to graph and take absolute values of graphs. Okay? Now we're going to do linear graphs and we're going to do quadratic graphs. They both have distinguishing features. So we'll start and go through the steps or the procedures in which we do it. So take a look at page 286. And it says, consider the absolute value function of y equals 3 x minus 1. All right. Okay. Says determine the y-intercept and the x-intercept, sketch the graph, state the domain and range, express as a piecewise function. Okay. So what I want to do is I'm going to approach this the same way I would approach it in grade 12. And that is I'm going to graph the original. So the original is whatever's inside the absolute value. So I'm going to graph that first. So I'm going to graph y equals 3x subtract 1. That's the first thing I'm going to do. So my starting coordinate is 0 and -1. It's right there. My map, my slope tells me go up 3, right 1, up 1, up 2, up 3, and then right 1 to here. Okay, so that is 3, that's 1, that's -1. So I have my two coordinates here and here. Now I'm going to draw my line through them. So there I have it. I've now graphed y equals 3x subtract 1. That's the first step. All right. Now I'm going to go through the solution with you on page 286 where we can fill it in. I'm also going to go through, and what I'm doing is actually method number 2. So this is on page 287. So flip to 287. Excuse me. Now I want you to fill in the blanks. So it says, sketch the graph of y equals 3x subtract 1 with a slope of 3 and a y-intercept of -1. Use the x-intercept from part A, which we haven't done yet. Okay, so we can do that first. All right, I want to find out what the y-intercept is. Or sorry, the x-intercept. That's right here. That's the coordinate I want to find out. So I put 0 in here for y, because y is 0 along this axis. I add 1. I divide by 3. So my x-intercept is 1/3 and 0. So it says use the x-intercept from part A. So put 1/3 and 0 in your space. Now it says reflect all the points below the x-axis in the x-axis. Use red to show the parts of the graph that represent y equals 3x subtract 1. Well, I've already used red, so I'm going to use green now. So the next step. The first step is this. Graph the original y equals 3x subtract 1. I don't necessarily need to do this. They do it because they're asking you to. I do this after the fact. I'm going to graph this first, and then I look at this graph right here, and I look at where the x-intercept is. And I know that because I'm using an absolute value, I cannot have, I got to maybe move this a bit. That's better. If I'm using an absolute value, I can't have negative values down here. All these negative values become positive. So I'm going to take this one in particular, where on this graph, y was equal to -1 here. That now becomes +1. 1, 2, 3. Well, sorry, I have this wrong right here. This should have been a 2 here. Okay, sorry. I digress. All right, so I go to here because that's my new positive. And I take this graph right here and I flip it up. So my new graph looks like this. And that is y equals the absolute value of 3x subtract 1. So all I'm doing is wherever my original graph hits this x-axis, I flip whatever's down here, I flip it up into the positive y. And that's all there is to it. All right, so it says any real number can be substituted in x into the function y equals absolute value 3x subtract 1. Therefore, what is the domain of this graph? Well, how far left does this graph go? Negative infinity. How far right does this graph go? Positive infinity. Therefore, x is an element of all reals. For all values of x, for the absolute value of x, 3x minus 1, where y is greater than or equal to 0, y is greater than or equal to, well, rather than put the lingo in here that makes it sound like jargon, let's just talk about this. All right, so my domain for this graph, we've already established, is x is an element of all reals. My range for this graph, how low does it go? 0. How high does it go? Positive infinity. So how do I write that? Y is greater than or equal to 0, where y is an element of all reals. That's my domain, my range for this. Therefore, the range, so you can see if you want to fill in your blanks, the range, y such that y is greater than or equal to 0, y is an element of all reals. All right, to me, this is the easiest way to graph an absolute value. Graph whatever's inside the absolute first, without the absolutes, and then once I've done graphing it, I flip it up at that point. Okay, so that's method number 2. It does say this. All right, so it does ask for this piecewise again. And again, I get this. You are going to have difficulties understanding what piecewise is. So I'll do my best to kind of slowly go through each question. I'll talk about it. But again, it's not one of my priorities just yet. So piecewise means this. I have actually 2 equations that I am going to piece together to get my absolute value. So looking at this right now, all right, equation number 1 is this guy. Well, that guy was y equals 3x subtract 1. Equation number 2 is this guy. So what is the equation of that line? Y equals, and this works every single time. So as long as you do it the same each time, it will be less difficult for you to understand. This line here is always going to be the negative of whatever that one is. So I write it like this, negative bracket 3x subtract 1. Okay, so there's my 2 graphs. And I borrowed a piece of each of those 2 graphs. So now I explain what piece did I use. So you can look on your book. I'll do it the same as the book now. It says y equals, big squiggly bracket, 3x subtract 1, negative 3x subtract 1. This is in your book. At the very bottom there, comma, comma. Now I have to explain what part of each graph did I use. Well, this is my 3x minus 1 graph. I used from here. That's where this comes in right here. So I used x is greater than or equal to 1/3. That's the part I used for that graph. Okay? What part of this line did I use? Well, I used from here to the left. So x is less than 1/3. So I pieced this together using y equals 3x subtract 1 and y equals negative 3x subtract 1. I used for this graph from this line right here I used y is greater than or equal to 1/3. And for this graph right here, I used y is less than or equal to 1/3. Okay. Now your alternative for this, and again, I'm not going to use it. I think you can follow through. If you look at method 1 on 286B, the alternative to this is to graph y equals the absolute value of 3x minus 1 and put it on a table of values. That's okay to do. You're going to need to make sure that you go enough into the negatives and enough into the positives so that you get it to work. So that is your alternative for that graph. All right. Okay, so this is a line. This is a linear graph. Now, I'm not going to use okay, let me just, any questions about the line part of it? Because we have to graph a parabola next. So I want to make sure that we've kind of hammered this out. We'll exclude the piecewise for a second. Do you understand that we graph whatever's in the absolute value first, graph it. So in this case, it was just a line. That was the red line. And then we reflect it or we flip up all of the values that were down here. All the negative values of y become positive and we flip it up. Okay, are there any questions about that so far?
I might just leave because I can't really see what's going on the board right now, so I'm going to just watch your YouTube video later.
Okay, can you put the YouTube on right now? Live?
Well, that's what I would have been doing, but then it was like every 2 minutes I'd have to set it to live and then I would miss some of it, and I just don't know what you're doing right now, so I'm just gonna watch the YouTube video from the start and everything.
Okay, sounds good. Maybe. So I'm actually only gonna. You may want to hold on. I'm only going to show one more example, Amber. Oh, left already. Okay. Okay, so here's the next step. Now this is the part that I'm not going to follow in your book just yet. I'm going to do one that's simpler than the one in the book, and then I'll go through what they're doing in the book. All right, because of course they make the one in the book not as nice to work with. So I'm going to start with a very easy one, and that is this. Once again, here, there, there. All right. My intended goal is to graph y equals the absolute value of x squared subtract 4. So to begin with, all right, x squared subtract 4 has a vertex at 0 and -4. Has intercept values, x-intercept values of plus and minus 2. So I've got 3 coordinates, which is all I need to graph a parabola. So I'm going to graph it. All right. So there's my parabola. Okay. Now I need to, so this is the graph of y equals x squared subtract 4. All right. Now what I want to do. Okay, so this is what happens here. Is I'm going to look at the bottom half of this graph. That's all my negative values. and I'm going to flip those negative values up into the top quadrant. So my 0, -4 becomes 0 and 4. And all of these negative values right here all become positive. And the ones that are already positive stay as positive. So to begin with, this is the graph of y equals the absolute value of x squared subtract 4. All right? So there's the first part of being able to do these. So I can now answer all of the questions that are in there. It says, determine the y-intercept. Well, what's the y-intercept? It's now 4. What are my x-intercepts? Plus minus 2. So 2 and 0 minus 2 and 0. It says graph the function. Well, I've already graphed the function. That's this right here. So let me just do this, put that here. I'll write it in red because that's exactly what I did. All right. It says determine the domain and range. So what's the domain of my new graph? How far left does it go? X is an element. Right is positive infinity. Therefore, X is an element of all reals. How low does it go? Goes down to 0. How high does it go? Well, the arrowheads tell us that it goes to positive infinity. So y is greater than or equal to 0. Y is an element of all reals. Expressed as a piecewise function. Okay, we're going to try this one more time. All right, my original graph was y equals x squared subtract 4. That was my original graph. Let me just write that here. Y equals x squared subtract 4. My other part of my graph is this. So that would be the graph of y equals negative x squared subtract 4. All right. Okay, so all I've done is I've taken this part and extended it down because it creates an upside down parabola. So I have two graphs. And again, I said, you always get that equation as the negative of this equation right here. It always works that way. So piecewise, y equals, big squiggly bracket, x squared subtract 4, negative x squared subtract 4. Okay, so there's one glaring difference between the linear and the parabola, and that is this. So for y equals x squared minus 4, I used that part of the graph and that part of the graph. So I write it like this. X is less than or equal to negative 2. X is greater than or equal to 2. Because I used from here and here. I did not use this part of the graph down here. All right? For y equals negative x squared subtract 4, I used in between those two values because I used this hump part. That's the part that I used right here. So I write it like this. How far left? Minus 2. Less than x, less than 2. There's the piecewise part of it. Okay? Again, not a priority yet. something that you're capable of understanding as we go, but not yet a priority for this. Okay? So as you can see is by using method number 2, which is graph the original and then flip all the negative values up, it's actually a fairly simple question to graph the absolute values here.
I just have a quick question.
Yeah.
When you write your piecewise function, how come the top line is x and then it's either less than or equal to or greater than or equal to, but then on the second part it's only less than or greater than?
You can use it once. You use the equals to one time. So you either use it for the top one or the bottom. I always use it for the top, then I never get it wrong.
Okay, because you can only have one value for that spot.
Right, because if I use it for this one, if I use the -2 out of this one, meaning equal to, then that means I'm not using it for this one.
Right, okay.
Okay, so that was a question I was waiting for. That's a great question. Okay, I wanted you to see that. So that this equals to has to be for one or the other, not both. All right. Okay. And that basically is it. That's what we need to look at today and be able to do. We can let's go through that second example. So we'll take our time, we'll fill in our blanks on the second example, and then that's all I want to really look at this morning with you. Okay? All right, so it gives us an equation. So the original equation. Absolute value, x squared minus 3x subtract 4. All right, so all we're going to do is we're going to fill in our blanks. I've shown you the easy way to graph. I wouldn't change it, okay? I would leave the graph the way I've shown you as is. This is just to show you a little bit of algebra on how to get your intercepts. That's basically all I'm using this for. Plus, it has a little bit of completing the square in it, and we'll go from there, okay? So, in part A, it says determine the y-intercept. So, to get the y-intercept, I substitute 0 in for x. You can't see me. I'll substitute 0 in for x. Y equals 0 squared minus 3 times 0, subtract 4. Absolute value, -4. My y-intercept is 4. So what we're going to do is we'll go through all of this and then we'll look at it after. And we'll see if it all makes sense. Okay. So filling in your blanks, you have 0 squared, subtract 3 times 0, subtract 4. You get f of x equals negative, the absolute value -4. F of x is equal to 4. The y-intercept occurs at 0 and 4. So you can fill in your blanks as you go down right there. All right. Now it wants to determine the x-intercept by substituting in y equals 0. So 0 in for y. Absolute value of x squared minus 3x subtract 4. All right. Now, this is the part that, algebraically speaking, there's something that we're going to have to do, but we're not going to get into it today, and I don't want to. But to get rid of my absolute value, basically what I do is I let it equal to the positive and I let it equal to the negative on that side. Means nothing to you because there's a 0 there. So what that means for my question right now is I can get rid of the absolute value right now without having to do anything. So I just change this into 0 equals x squared minus 3x minus 4. Now that you have it right there, what do we do to find our intercepts? We factor. 0 equals x and x, -4 plus 1. Therefore, my x-intercepts 4 and -1. All right? So first blank, y equals 0 into the function and solving for x. 0 equals the absolute value. 0 equals x squared minus 3x subtract 4. 0 equals x subtract 4, x plus 1. Therefore, x minus 4 equals 0, or x plus 1 equals 0. X is equal to 4. X is equal to -1. X-intercepts occur at 4 and 0, and -1 and 0. So if I were to graph this right now, just as it is, just using intercepts. Okay, so 0, -1, right there. Sorry, -1 and 0. So there's one x-intercept, there's another x-intercept, and my y-intercept is right there. So that's part of the information that I have so far. But that's 3 coordinates, but that's not really 3 great coordinates in order to graph my parabola. I usually want to find out what my vertex is. So to find my vertex, I'm going to do the completing of the square of this to do it. All right? So I go y is equal to x squared minus 3x plus a blank minus 4, subtract a blank. In this case, it's 3 over 2 goes in there, squared. That's 9 over 4 out here. Equals x minus 3 over 2 squared minus, so that's 1625 over 4. Okay, so my vertex, I'm going through this very, very quickly. I understand that. All right, I know it's quick. All right, I'm sorry, I want to do it. We're going to run out of time if I don't get this moving a bit. Okay, so here's my x value of my vertex. Again, it's half that value squared, right? Subtracted on the outside. So I've got 1.5. Sorry, I've got one error here. Where's my error? Oh, that's why. My apologies, I messed this up right here. That is not... Four and -1. And I don't think that's right either. Hold on. So 4 and -1 are my, where are we? Right here. 4 and -1 are my 2 intercepts. So there's 4, -1. My vertex, 1.5 and -6.25. So my vertex is 1.5, so that's down here. And -6.25, that goes right here. All right? Again, there must be an error over here. My y-intercept. Oh no, because we got to flip it after. My bad. Okay, so there's where I'm at right now. So this would be, this right here is -6.25 on the y and 1.5 on the x. But I then need to take, so that now that I have all of those, okay, this would be my original graph. Looks like this. And again, this is why I don't like doing all of this work, because errors get made and it looks confusing. But what I have just done is created my original graph. Now, I've got to flip this part right here, and I end up with that graph right there. because it's the absolute value of it. So I've gone through, done that, flipped it, ended up with my new absolute value graph. So then I'd have to go through all of this information. It says any real numbers can be substituted for x into the function, the domain. So if I look at page 289, I could go through all of that and explain it all. But to me, I would have just graphed the original first, which is what I did. That's in red, and then flip that part up, okay? Rather than going through all of this. Now, again, this is a section that it would be of assistance to use your graphing calculator, but it's not necessary, okay? So I'm going to let you work on this until Tuesday because it's one of those sections that are fairly important to what you're going to do in grade 12. So I want you to make sure that you can get a good grasp of it and understand how to do the absolute value of it, because we get into more complicated absolute value graphs in grade 12. But you need to be able to do the very basics. All right? So that's all I have for today on 7.2. Anything from 7.1 yesterday that you want to ask about this morning?
I was doing the assignment, and then there's like that one question where you have to like set up that table kind of thing. But do you think you could do number 7 on page 272, just so that I can understand it a bit better? I think it's from 6.4.
Yeah. Okay.
So I was having trouble with like the distance and speed.
Yeah. No.
That was confusing.
Yeah, I know what you're saying. Okay. So okay. So to set up your chart, you've got with your current, against your current, and then you've got your total. So I got distance, I got speed, and I got time. Okay? So it says, Marique and Kate canoe 8 kilometers up a river against the current and 8 kilometers back with the current. Okay, so we know that it's 8 kilometers and 8 kilometers for a total of 16 kilometers. If the speed, I'm going to ignore the time for a second. If the speed of the current is 2.6 kilometers per hour, what is her average speed in still water? So with the current, she's traveling at her paddling speed plus 2.6. Agreed?
Yeah.
And then against the current, she'd be paddling at her speed minus 2.6. So far, so good?
Yeah.
Okay. How do I get time? How do I get time for anything?
Would it be distance divided by speed?
Yes. So I'm going to take 8 and I'm going to divide it by x plus 2.6. And then I'm going to take 8 and divide it by x minus 2.6. So far, so good?
Okay, yeah.
All right. And the total time it takes is 2.5 hours. Okay?
Okay.
So now you add these two.
I'm going to take like the 8 over x minus 2.6 and then add 8 over x plus 2.6?
That's correct.
Okay.
Yeah. All right. Does that make sense?
Okay, that makes more sense, yeah. So then I just take like, do I have to like multiply
By your common denominator.
the common denominator? Okay.
Yeah, which will be x plus 2.6 times x minus 2.6.
Okay, that makes a lot more sense now, thank you.
Perfect. All right, no problem. Anybody else have questions this morning? No? Okay, well, what I would like you to do, if you're done your assignment and you've already sent it to me, then work on 7.2. I'm going to leave you on live for 10 minutes. I have to shut you off at 9:55 so that I can get my 10 o'clock class started. So I am on here. So be aware I am on here for your comments, but I'm going to mute my my volume, okay, or my microphone. So if there's no other questions, you've got 10 minutes. I'll be on here with you, and then I have to shut down the video. All right?